In a previous video, we looked at the basic ideas of electrolysis. To quickly recap, electrolysis is the splitting of ionic substances using electricity. The electrolyte is the substance being split up and must be in the liquid or aqueous, which means dissolved in water, state. The anode is the positive electrode. Negative ions attracted to it are called anions. The cathode is the negative electrode. Positive ions attracted to it are called anions. When there's more than one anion or cation, there is a system to work out what's being produced. At the cathode, the least reactive element is produced. So, for example, if you've got hydrogen and sodium ions, hydrogen is less reactive than sodium, so hydrogen will be produced and sodium will be left in the solution. At the anode, if there's a halogen present and the solution is concentrated, the halogen, fluorine, chlorine, or iodine, is produced. If the solution is dilute, or there is no halogen present, then oxygen is produced, which comes from the hydroxide ion. So all of that was covered in a previous video. Go back and watch that for more detail. What I want to cover today is half equations. A half equation is a chemical reaction which tells us what the electrons are doing. You see them most often in electrolysis, but you can actually write them for any kind of redox reaction. As the name implies, they are two halves of a reaction, showing us the adding or removing of electrons, which is what happens during electrolysis. The main thing to keep in mind is that during a half equation in electrolysis, you're always trying to make the ion become neutral. And remember that electrons are negative, so positive ions will gain electrons to become neutral, and negative ions will lose electrons to become neutral. The other things to keep in mind for this is that some elements are diatomic, and this needs to be considered when you're balancing your half equations. Diatomic means that they create an element that has two atoms joined together. They exist in pairs. There's only 7 diatomic elements that you need to remember. They are hydrogen, oxygen, nitrogen, and then all of the halogens, so fluorine, chlorine, bromine, and iodine. They do come up a lot in half equations, though, especially in electrolysis. The last thing to remember when trying to make your half equations is that hydroxide is a special case, so you just have to memorize it. I think it's probably best to take a look at some examples. All of the examples that I'm going to look at are going to be in solution. If the electrolyte is not in solution and is molten or a liquid, then there will only be 2 ions present, and figuring out which one's produced is pretty straightforward. The half equations will still follow the same rules. So for the first example, let's take a look at sodium chloride solution. If we electrolyze sodium chloride solution, first we've got to identify the ions. In this case, there is sodium and chlorine from the ionic sodium chloride. Then there's also hydrogen and hydroxide from the water. There's always hydrogen and hydroxide if water is present. At the cathode, positive cations will be attracted there. So we have to decide which one is produced. The positive cations here are the Na plus and the H plus. Remember our rules, hydrogen is less reactive, so we will get hydrogen. So let's take a look at how to make the half equation. Hydrogen is positive, H plus, so we add an electron to make it neutral. Hydrogen is also on our list of diatomic elements, so we actually make H2 rather than H. This means that we've got to balance the hydrogens and the electrons, and we do that like this. So the half equation at the cathode overall is this. You see it there. 2H plus 2 electrons gives us H2. That's the equation at the cathode for the electrolysis of sodium chloride solution. At the anode, we've got the chloride and the hydroxide, the negative anions. Opposites attract. The rule is there a halogen? Yes, there is. Chlorine is a halogen. Halogens are the group 7 elements. So we make chlorine. The chloride ion is negative. So we have to remove an electron by putting it on the right of the half equation, like this. So we're losing an electron there. Again, chlorine is diatomic, so it has to be balanced like this. So these are the 2 half equations at each electrode for the electrolysis of sodium chloride solution. Let's take a look at another example to show the different types of half equation. If we electrolyze copper 2 sulfate solution, CuSO4, again it's in solution. The ions present are copper 2 plus and sulfate from the copper sulfate, and as usual, because there's water, we get hydrogen and hydroxide from the water. At the cathode, The less reactive of those two elements is copper. Copper is positive, so it needs to gain electrons. This time, it gains 2 electrons to be neutral. So the half equation looks like this. We're adding 2 electrons. Copper, not a diatomic element, so we don't need to balance it that way. Half equation looks like this. At the anode, this time, no halogen present. No halogen in this at all. So it's going to be the hydroxide that gets discharged. Remember I said earlier that the hydroxide is a special case. You need to just learn it. You need to just memorize it. Well, its half equation looks like this. It produces oxygen gas. It also produces water, but the water doesn't come out of it. The water stays in the solution. So the two half equations for the electrolysis of copper to sulfate solution look like this. That second one will always be what you get when you electrolyze something with hydroxide in and there's no halogen. One more thing, you might get asked for an observation, and an observation is what you can see happening. If you were doing this on a desk in front of you, what you would see happening. That's most likely going to be a color change, bubbles being produced, or a solid being produced, particularly, for example, copper. Copper's a brown solid gets produced. So to sum it up, to make a half equation, you simply add or remove electrons until it is neutral. You balance it, being careful with the diatomic elements, and remember that hydroxide is a special case. Thanks for watching.